Hello, algebra students. We are continuing in another day of learning about substitution with systems of equations. So we're still doing that thing where we're replacing a value, and I'll just highlight it because that's what this is called. We are doing substitution. So what I'd like for you to be able to do by the end of today is to be able to solve a system of equations using substitution, but now there's going to be one extra step where you have to solve for a variable to substitute in for. And you're going to see what I mean by that when we jump into these steps. So here are the steps that you're going to want to follow. First of all, notice I have two equations. I've got 2x plus 2y is equal to 10, and 3x plus 5y is equal to 19. All right. Before, yesterday in our lessons, it would have looked like this. It would have been like y is equal to 5 plus x. And so notice how this y is already isolated for you. The y is alone, ready for you to substitute in its value. Now we're going to have to isolate the y first. So you want to look at your two equations and then just ask yourself which one is probably going to be easier to solve for a variable in. Some things that you can look for are the specific numbers. So notice how in this problem I have 19, which is a prime number. So I know that 19 does not divide evenly. It's not a very convenient number. So maybe I could try this one instead. Notice how it has 2, 2, and 10. All of those are even numbers, so that one could be an easier one for me to solve for. Okay, I'm just going to choose to solve for y, and I just have to do one of them for this. So I'm going to take this, and I'm going to say solve for y. That's your first step. So we're going to start isolating the y. The way I do that is subtract 2x from both sides. So now I have 2y is equal to 10 minus 2x. And then I'm going to divide by 2 everywhere. And that gets me y is equal to 5 minus x. Okay. I now have y is equal to 5 minus x. Now I'm able to take that expression and take this y and replace it in for this one. So I'm going to write this expression down here. So my second step is substitute the expression in for the variable in the second equation. So I want to take this y equals 5 minus x, and I'm going to stick it in right here for that y, because I'm taking this y and I'm replacing it. So now I'm going to get 3x plus 5. Instead of the y, I wrote 5 minus x. Whoa, sorry, you guys, you can't see it. Let me do that again. I have 3x plus 5 multiplied by 5 minus x. So instead of writing y, I wrote 5 minus x is equal to, and then 19. Okay, now it's time for me to start solving my equation for x. So this is 3x plus 25 minus 5x is equal to 19. I just distributed my 5. Now it's time for me to start solving for that x some more. I'm going to combine like terms, so that's negative 2x plus 25 is equal to 19. I'm going to subtract 25 from both sides. So now negative 2x is equal to negative 6. Divide by negative 2. X is equal to positive 3. Okay, from this point on, it's all the same as what we had before. If x is equal to positive 3, I'm going to take that value and stick it into x here. So now this is 2 times 3 plus 2y is equal to 10. This is 6 plus 2y is equal to 10. Subtract 6 from both sides. 2y is equal to 4. Y is equal to 2. Now I have my ordered pair. x is equal to 3, y is equal to 2. Now I'm going to substitute those in for my ordered pair. So 3, 2. This 3, 2 is the solution to the system of linear equations. Now, because of this additional step that we have, it is even more important that you check your work from this point on, because there are lots of places that you can make mistakes. There's lots of places I can make mistakes. So I strongly encourage you to substitute your values in just to make sure you got them right. So I'm just rewriting these expressions real fast down here for us. So I have 2 times x, which is 3, plus 2 times y, which is 2, is equal to 10. And I have 3 times 3 plus 5 times y, which is 2, is equal to 19. Let's check and make sure that's correct. So this is 6 plus 4 is equal to 10. 10 equals 10. That's good. And then I have 9 plus 10 is equal to 19. 19 is equal to 19. That one checks out as well. So I now know 3, 2 is in fact correct and not a mistake. We're going to keep working examples like that just so you can get used to them. So this is why we've been practicing solving for variables in our DMR, because that's what we're doing in these. So I'm looking at my 2 expressions and I'm asking myself, which one is going to be easier to solve for a variable? Notice on this one, the y does not have any coefficient in front of it. It's all alone. The only thing that I would have to do to isolate this y is add 2x to both sides. So another thing you're looking for is a variable that does not have a coefficient. And that would typically be the one you'd want to isolate. So that's what I'm going to do here. I'm going to add 2x to both sides. And now I have y is equal to 2x plus 3. This is the form that I need it in to be able to substitute. I've got y is equal to 2x plus 3. Now I'm going to take that value, 2x plus 3, and I'm going to replace this y with it. So my new equation is going to be 3x minus 2 times 2x plus 3 is equal to 5. Let's start solving. I have 3x minus 4x minus 6 is equal to 5. Well, 3x minus 4x, I can combine those terms. So that's going to be negative 1x minus 6 is equal to 5. Add 6 to both sides. Now I have negative 1x is equal to 11. To get rid of this negative 1, I need to divide both sides by negative 1, not add 1, because this means multiplication. The opposite of multiplication is division. So now I've got x is equal to negative 11. Awesome. I'm halfway done with my problem now. I'm going to take this x equals negative 11, and I'm going to substitute it back into this equation. The reason I want to do that is because you don't want to put it back into something where you could have made a mistake. Always use the original problem to substitute back into. So here I have y minus 2 times negative 11 is equal to 3. So that's y plus 22 is equal to 3. And that's going to get, I'm going to subtract 22 from both sides. Y is equal to negative 19. All right. My ordered pair for my answer is now negative 11, comma, negative 19. But I always want to check my work on these because there are a lot of steps. So I'm going to take my, whoops, there went my calculator. Okay. I'm going to take my values, and I'm going to stick them into both of my equations. So I have negative 19 minus 2 times negative 11 is equal to 3. That was my first problem. And then I have 3 times negative 11 minus 2 times negative 19 is equal to 5. Oh, I needed to put some space in there. I apologize. Let me rewrite that a little bit lower so I can work through these. Okay, so this gets me negative 19 plus 22 is equal to 3. That will get me 3 equals 3, so the first one checks out. This one is negative 33 plus 38 is equal to 5. That gets me 5 is equal to 5. That one works out as well. So that means my solution of negative 11, negative 19 is correct. Let's keep doing examples like that in these next ones. So your first step is to solve one of the equations for a variable. But which one? Once again, look for a variable with no coefficients. Notice how the 7 is in front of the x here. A negative 2 is in front of the y. A 2 is in front of this y. And there's nothing in front of this x. Because there's nothing in front of this x, it will be the easiest one to solve for. So this x is the one I'm going to isolate. So I'm going to add 1 to both sides. And that gets me 2y plus 1 is equal to x. Awesome. This 2y plus 1 is equal to x is what I needed. I'm now going to replace this x right here into the top equation. So my top equation is going to be rewritten like this. It's going to be 7 parentheses. Now I'm writing my expression 2y plus 1 minus 2y is equal to 1. Distribute your 7. So I have 14y plus 7 minus 2y is equal to 1. That gets me 12y plus 7 is equal to 1. Subtract 7 from both sides. 12y is equal to negative 6. Divide by 12. Y is equal to negative 1/2. Don't freak out. It's okay that it's a fraction, and it's an easy fraction at that. It's just negative 1/2. Okay, I'm going to take this, and I'm going to substitute it now into this lower equation. So this is 2 times negative 1/2 is equal to x minus 1. 2 times negative 1/2. Ignore the negative for a second and ask yourself, what's half of 2? Half of 2 is 1. Now make it negative because of that negative sign. So now I'm at negative 1 is equal to x minus 1. Isolate the x, so I add 1 to both sides. 0 is equal to x. Cool. I have my two values now. I have my ordered pair. 0, negative 1/2. Let's go on to example B. Now I do have to tell you there is a little typo in this. Once again, that needs to be a plus sign. If we make that a plus sign, it will be better. All right, look at your coefficients in front of your variables. I have a 6 here, a 5 here, a 2 here, and nothing in front of this x. This x will be the easiest one to solve for. So I'm going to subtract 1 from both sides. So now I have 2y minus 1 is equal to x. I can take this 2y minus 1 and replace this x with that expression because x is the same thing as x, and x is equal to all of this. I can take this and replace the x because they are the same. When two things are the same, they are interchangeable. So my new equation is going to be 6y plus 5 times 2y minus 1 is equal to 43. Let's start solving for y. I want to distribute the 5. So 6y plus 10y minus 5 is equal to 43. 16y minus 5 is equal to 43. Add 5 to both sides. 16y is equal to 48. Divide by 16. You might need to get a calculator. What is 48 divided by 16? It is 3. So now I have y is equal to 3. That's my first variable. I now need to take this y equals 3 and stick it back into this second equation to figure out what x is equal to. So now I have 2 times 3 is equal to x plus 1. 6 is equal to x plus 1. Subtract 1 from both sides. 5 is equal to x. So my ordered pair is going to be 5, 3. Let's check our work to make sure that we got that all correct. So I'm going to take the 3 from the y and substitute it in here. And I'm going to take the 5 from the x and substitute it in here. So this becomes 6 times 3 plus 5 times 5 is equal to 43. That is going to be 18 plus 25 equals 43. And that gets me 43 is equal to 43. Cool. Okay, so that first one works out. Let's check the next one. 2 times y, so it's 2 times 3 is equal to 5 plus 1. 6 is equal to 6. That works out as well. So I now know that 5, 3 is correct. Looking at example C, I have x plus 4y is equal to negative 16, and 4x plus 7y is equal to negative 19. Okay, we're using that same strategy. Which variable in whatever equation is going to be the easiest to solve for? Clearly, it's going to be this x. So I would subtract 4y from both sides, and that's going to get me x is equal to negative 16 minus 4y. I can take this expression and I'm going to replace this x because x is equal to x. That's why I'm allowed to do that. Okay, so now I'm going to rewrite this bottom expression, but instead of writing x, I'm going to write my negative 16 minus 4y. So this becomes 4 parentheses, negative 16 minus 4y plus 7y is equal to negative 19. I need to distribute, and we're getting some bigger numbers, but that's okay. You can just use your calculator. 4 times negative 16 is going to be negative 64, and I can double check that. And then 4 times negative 4y is negative 16y plus 7y is equal to negative 19. I have like terms on the left side of my equation, so I want to combine those. Negative 64 minus 9y is equal to negative 19. Now I'm going to add 64 to both sides. That gets me negative 9y is equal to 45. Divide by negative 9. Y is going to equal negative 5. Now that I have the y is equal to negative 5, I'm going to take it and replace it back up here into my first problem. So here I have x plus 4 times negative 5 is equal to negative 16. Well, 4 times negative 5 is negative 20, so that's going to be x minus 20 is equal to negative 16. Add 20 to both sides to isolate the x, and I get x is equal to 4. Okay, now I put those two values together to form a coordinate, and my coordinate is 4, negative 5. I do want to check my work real fast because there were a lot of negatives and the numbers were getting kind of big. So this would be an easy problem to make a simple math mistake on. So I just take my 4 and I replace the x with it, and the negative 5, I replace the y with that. So it's 4 plus 4 times negative 5 is equal to negative 16. 4 minus 20 is equal to negative 16. That one works out. Then here, I have 4 times 4 plus 7 times negative 5. 16 minus 35 is equal to negative 19. That one works out. Negative 19 is equal to negative 19. Cool. We have one more example to do, and then we are done with today's notes. On this one, we are looking for a variable with no coefficient. This could look a little tricky because of this negative x. We wouldn't want to solve for the negative x because that negative sign, but we could easily solve for the y. So you just add x to both sides, and that gets you y is equal to 5 plus x. I'm now going to take this 5 plus x and replace this y with it because the y was isolated, so I can substitute in my values for it. So my new equation is going to be negative 4x plus 3 times 5 plus x is equal to 21. We now want to start solving for that variable, which is x. So I have negative 4x plus 15 plus 3x is equal to 21. Negative 4x and 3x is negative x plus 15 is equal to 21. Subtract 15 from both sides, and you get negative x is equal to 6. I don't want negative x, though. I want positive x. So divide by negative 1 on both sides. I get x is equal to negative 6. All right. Now I'm going to take this x equals negative 6 and stick it back into this top equation. So I have negative 6, the negative of negative 6, my apologies, plus y is equal to 5. So the negative of a negative is positive, so now I have 6 plus y is equal to 5. Subtract 6 from both sides, have y is equal to negative 1. So my ordered pair for D is going to be negative 6, negative 1. Maybe I should, I got a lot of writing on this paper. Maybe I should block in those answers for you a little bit better. Okay. I do want to go ahead and check my answer because once again, there were a lot of negatives and there's a lot of easy places to make mistakes. So just substitute your values back in real fast. The negative of negative 6 minus 1 is equal to 5. That is 6 minus 1 equals 5, which is correct. Then in the bottom one, I have negative 4 times negative 6 plus 3 times negative 1. Well, negative 4 times negative 6 is positive 24. 3 times negative 1 is minus 3. 24 minus 3 is 21, so that's correct. So notice how a lot of today was very similar to yesterday. The only new step is solving one of the equations for one of the variables, and we'll keep practicing with this. So if you have questions, bring them to me tomorrow in class, and have a good night.